Welcome to This Explainer. Today, we're setting the stage for humanity's ultimate hero's journey. We're looking at the conclusion of Stephen Hawking's monumental work, moving beyond the complex physics to look at the sweeping narrative of our entire species, the quest to truly understand the universe, our place in it, and honestly, why it even exists at all. Let's get right into it.
So, to start us off, let's dive into this existential cold open. As Stephen Hawking himself asked, what is the nature of the universe? For literally all of human history, we've been staring up at the night sky trying to make sense of a deeply bewildering reality. This isn't just about cold, hard math, It's about our fundamental human craving for order and meaning in the cosmos.
Act 1. From spirits to strict laws. Well, to appreciate where we're going, we first have to understand exactly where we started. This first act of our intellectual journey acknowledges the dark, confusing world our ancient ancestors first tried to comprehend. Before there was physics, there was frankly just fear and mythology. In the early era, humanity believed that natural events, stuff like storms and seasons, were controlled by completely unpredictable human-like spirits living in rivers or mountains. You literally had to placate them just to survive. But moving into antiquity, observers started noticing some comforting regularities. The sun rose and set whether you sacrificed to it or not. Eventually, this steady march of observation led us to the 19th century, where the Marquis de Laplace postulated something totally incredible: scientific determinism. This was this super comforting idea that if you just knew the exact state of the universe right now, strict scientific laws would dictate its exact future. Think about Ptolemy's early cosmological model, which brilliantly illustrates this massive shift in thinking. His neat, orderly spheres carrying the planets and stars, even though, it placed the Earth at the center, which we obviously later learned was completely wrong, laid the vital groundwork for Laplace's dream. It gave humanity the idea of a completely predictable, clockwork universe, a universe of strict rules, not unpredictable whims.
Act 2. The twist. The fall of determinism.
Okay, so just as we thought we had the whole universe perfectly mapped out, science hit a massive, totally unavoidable obstacle that shattered our comfortable illusion of perfect predictability. While Laplace promised us absolute certainty, in the 1920s, Werner Heisenberg and quantum mechanics kind of crashed the party. Heisenberg's uncertainty principle proved that it's physically impossible to measure both the precise position and the precise speed of a particle at the exact same time. You literally cannot know the exact present state of the universe, which means, by definition, you cannot perfectly predict its future. Quantum mechanics threw rolling dice right into the fundamental workings of nature.
And because we can't pin down these microscopic particles exactly, we have to treat them differently. They actually behave a lot more like overlapping waves of probability. Sometimes the wave crests reinforce each other, sometimes they cancel out entirely. So quantum mechanics introduces this unavoidable element of randomness into the cosmos. Albert Einstein famously hated this, famously declaring that God does not play dice, but, well, the experiments proved otherwise.
So determinism is basically dead on the microscopic level. But as we zoom out from that tiny quantum world to the massive, crushing cosmic scales, that's where our trusted laws face an even bigger crisis. Right, so the absolutely crucial point in all of this is a concept known as a singularity. General relativity predicts that the universe began in a Big Bang, a literal state of infinite density. It also predicts that giant stars eventually collapse into black holes, creating even more points of infinite density. A singularity represents a literal edge to space-time itself. It's an absolute wall where unpredictability reigns supreme, and all our carefully crafted scientific equations simply break down and die. I mean, think about it. If the laws of science break down at the very beginning of the universe, how could we ever possibly know how it all started?
Act 3. The elegant solution. So we clearly need a rescue mission for physics. To fix these incredibly messy singularities, Stephen Hawking focused his life's work on merging the two great partial theories of the 20th century, quantum mechanics and general relativity. He and his colleagues developed a beautifully elegant concept called the no-boundary proposal. By using what physicists call imaginary time, time actually starts to behave exactly like a direction in space. Imagine being able to walk backward and forward in time just as easily as you walk left and right. When you do that, the universe becomes a finite, four-dimensional space that's entirely self-contained. No singularities, no boundaries, and absolutely no edges. It mathematically smooths out the entire chaotic beginning of the universe.
It's kind of like the Earth. Think about it. The surface of the Earth is finite. It has a specific size, right? But it has no edge. You can walk all the way around the globe without suddenly falling off into some terrifying singularity at the North Pole.
Hawking proposed that the universe basically operates the exact same way in imaginary time. It starts at a single point, expands, and then contracts, but it simply curves back on itself with absolutely no messy boundaries or edges where the laws of science fail.
Now, this is where we have to pause and ask the big question. Why does this matter beyond just the cool mathematics? Well, if the universe had a definitive edge or a singularity at the Big Bang, you could easily say a creator chose to wind the clockwork at that specific boundary point. But if the universe is completely self-contained, if it has no boundaries and technically no distinct beginning where the laws break down, it simply is. What place, then, is there for a creator to intervene?
Seeking the unified theory.
That profound philosophical question brings us to the ultimate treasure of humanity's intellectual quest. If the universe really is a self-contained system of rational laws, our ultimate goal as a species is discovering the single, cohesive framework that explains all of them. If we can find this complete unified theory, it would end a glorious chapter in human history. We'd finally perfectly combine the massive scale of relativity with the tiny, unpredictable scale of quantum mechanics. We wouldn't have to plug in arbitrary fudge factors or random numbers just to make the math work out. But perhaps most importantly, once the theory is completely refined, it won't just be locked away for specialists. It'll be taught in high schools. Everyone, ordinary people included, will be able to grasp the fundamental laws that govern our very existence.
But even if we find that absolute perfect mathematical model, we're still left with an incredibly profound mystery. A unified theory is, at the end of the day, just a cold set of rules and equations on a piece of paper. It doesn't actually create anything on its own. So what is it that breathed fire into those equations? Why does the universe go to all the bother of actually existing for those rules to describe it? Does a perfect unified theory somehow compel its own existence?
And this right here is the true heart of Stephen Hawking's work. The search for unified theory isn't just about particle physics or the curvature of space-time. If we can answer why the universe exists to be described by these laws, it would literally be the ultimate triumph of human reason. Because in answering that, we wouldn't just finally understand gravity or quantum mechanics, we would know the mind of God. We'd finally understand our deepest, most profound purpose.
So, as we wrap up this explainer on the history of time in our ever-evolving picture of the cosmos, we're left staring right into the existential abyss. Science has moved us from fearing river spirits to mapping clockwork planets to wrestling with the weird probabilities of quantum mechanics and the literal boundaries of time itself. But the final frontier isn't just how the universe works, it's why. Why do you and the universe exist at all? Keep questioning, keep learning, and thank you so much for joining me on this incredible journey today.